Welcome back to Hobby Universe Outdoors. I'm Len, and today we're going to be talking about this Predator 3500 series inverter from Harbor Freight. Now, today's video, it's not going to be an in-depth video talking about the specifications of this unit or how to operate it, how to do an oil change. Really not going to cover any of that stuff today, but if you're interested in seeing any of those items or more, I did make a video previously where I go into a lot of detail about those items. I'll put a link to that video down in the description for this video so you can check that out. Today, I'm primarily going to be focusing on an issue I'm having getting the thing to start using the electric start button. And spoiler alert, we're going to be replacing the battery. But what I'll do is I'll work through my process for determining that the battery was actually bad, and then we'll kind of walk through the steps that you would take to get the battery replaced. It's not that difficult. We're going to get through it pretty quick. Let's get started. So I knew I had a problem because I wasn't getting anything out of that starter. So I rotated the knob to the start position. I hit the start button. I don't get anything. So the first thing I'm going to do is I'm going to remove this little door right here. That's going to give me access to the battery. There's only going to be one screw holding this door on. So we take our Phillips screwdriver, loosen that, and the door pops right off. And then also worth noting, that screw is captured in the door. Little details like that I certainly appreciate, because if it wasn't, there's a pretty good chance I would lose that screw before I was done. Now that we got the door off, we're going to remove this rubber strap. This passes over the top of the battery, and this clip attaches down to the bottom part of the frame. That's what holds the battery in. Once we have that strap loose, we can just slide the battery out. And now we're going to check the voltage. What I'm going to do now is I'm going to use my multimeter and I'm going to check the voltage on the battery just to see where it's at. But one thing I wanted to mention before doing that is the inverter will actually charge the battery. So it's not unusual for the battery to get a little bit low if you use the starter a lot, or if it's sat for quite a bit of time without you using it. When you run the inverter, it will recharge that battery for you. So this thing was run recently. It ran for a solid 8 hours about 2 weeks ago, which would be plenty of time to charge that battery back up. The reason I wanted to mention that is if you're testing your battery, you do want to make sure that you at least gave it the opportunity to get charged. So you want to run your inverter. That would charge the battery if it was able to accept the charge. If the battery's bad, which I believe is the case for me, well then no matter how much I run it, or if I put this on a battery charger individually, we're still not going to get the juice we need in here. But that's what I'm going to show you now. With the engine off, I'm going to check the voltage of the battery. And right there I'm showing 4 volts DC. That's not going to be nearly enough power to be able to start this engine. This is a 12 volt battery, 12 volt starting system, so I'm very short of where I need to be. We determined the battery does not have enough juice to start the engine. Before we automatically just go into replacement mode on the battery, I want to check one more thing. I want to make sure that the battery is the problem and that it's not something to do with the charging capabilities of the machine. Like I mentioned a few minutes ago, when this inverter is running, it's going to pump current back into the battery, keeping it charged. I want to make sure that that charging system is working the way we would expect. The way I'm going to test that is I'm going to start the inverter, and then I'm going to check the voltage at the battery again. If that power is at 13 or 14 volts DC when I test it with the engine running, that'll tell me that this is providing the current needed to recharge that battery. On the flip side of that, if I start this and check the voltage and I'm only putting out 3 or 4 volts or maybe 0 volts, well, that'll tell me there's something else wrong with the unit besides just the battery. With the engine running, we're going to check that voltage again. And we are at 14 volts, telling me the inverter is putting out the current needed to be able to recharge that battery. It's just a matter of the battery not taking that current and holding that charge for us. With that test complete, we're now certain that the battery is going to be the culprit and the reason we're having starting issues. The inverter, we confirmed, is providing the power needed to keep that battery charged. The battery simply is not doing its job of storing that energy for us. Removing the battery is pretty easy. You've got these little rubber boots. You pull those up out of the way. Use a Phillips head screwdriver to remove the hardware connecting the battery cable to the terminal on the battery. Now, in a lot of cases, when you're working with batteries like this, it'll have a little hex bolt on there. These are nice and simple. All you have is that Phillips head screw. And these screws are not captured, like I showed you on that battery door where the screw won't fall out. That's not the case on these battery cables. This screw will fall out, so you want to make sure you don't lose that. You remove those two screws. Now the battery's loose. But one other thing I want to caution you about is underneath these battery terminals are these rectangular nuts. And these rectangular nuts are needed to be able to attach the hardware passing through that cable to the battery terminal. So just be careful once you remove the battery. If you flip this up, those will fall out. You don't want to lose those. The battery I'm going to be installing in the inverter is one that I picked up on Amazon. The price was right around 25 bucks, which was fair. That's pretty average for what you would expect to pay for a battery of this size. But the main reason I landed on that battery specifically was that the specifications match exactly what this inverter requires. So that was an easy decision to make. That's the battery I got. I will leave an Amazon link down in the description of the video where you can pick up this same battery. It's not my Amazon store. It's not like that at all. It's the correct battery for this inverter. So if you're looking for one, might be something you want to consider. Something else I wanted to talk about real quick is that these are lead acid batteries. This isn't something you simply want to toss in your regular garbage so that it ends up in a landfill somewhere. You're going to want to make sure that you recycle it properly to make sure that lead goes where it's supposed to and not in a landfill. The battery comes wrapped in this clear shrink wrap. I'm getting ready to move that here in just a second. One thing I wanted to point out was that earlier in the video, when I was removing the battery cables from the battery terminals, was that there was these screws that we wanted to be very careful not to lose, and also these rectangular nuts. The good news is the battery that we bought comes with new screws and new rectangular nuts. So even if I was to lose one of these pieces of hardware, or one was damaged and needed to be replaced, I'd still be in good shape with this battery. It's another reason I'm glad I chose the one that I did. A couple things I wanted to confirm before installing the new battery. One, I wanted to make sure that the new battery was the same size as the old battery. So this side-by-side comparison's confirming that for me. So I know this new battery is going to go in the compartment in the inverter where it's supposed to. Another thing I wanted to look at was the location of the positive and negative terminals on the batteries themselves. And if they were reversed for some reason on the new battery compared to the old, I probably could rotate the battery. I would rather not, because I think that would reduce the amount of cable length I had available. But in the end, I think you could probably do that. Ultimately, when you're connecting the new battery, it's going to be really important to make sure that your positives and negatives are connected correctly into the inverter. In most cases, I would expect the new battery to come already charged. I'm going to check it with the voltmeter. And it is. It's at 13 volts DC, which is exactly what we would expect. Installing the battery is going to be exactly the opposite of what we did to remove it. Again, making sure that we line up or properly orient the battery so that the negative goes on the negative terminal and the positive goes on the positive terminal. I'm going to actually reuse the existing hardware. I did inspect the hardware, also the connections on the ends of the battery cables, making sure everything was in good condition. It really is. Everything looks brand new, so there's no issues there. If you did have any kind of corrosion or dirt or debris or anything on there, you'd want to clean that up first before installing the new battery. I'm going to take these little rectangular nuts, again reusing the existing ones. These are the nuts that I was terrified about losing before I realized the new battery came with new hardware. I'm going to slide these inside the battery terminal. That way the bolt or the screw that I put through there will have something to grab onto. And just like the removal, only in reverse, we're going to attach the battery cables. Get those nice and tight. I mean, you don't want to get on there crazy tight and damage anything, but you do want them secure enough so that you have good contact. You're going to get good current flow through that connection and that they're not going to wiggle loose because these things vibrate quite a bit as they run. So you get them nice and snug. Whoops. Then you press these rubber protective boots back down. Get the battery back in its home in that little compartment. Now we'll get this battery door reinstalled. Once we have that on, the only thing we'll have left to do is to test it. I'm getting ready to start this thing for the first time since installing that new battery. And in complete transparency, I've not already done this test before hitting the record button. This will be the first time that I'm going to try it with that new battery. Perfect. Thing fired up. That battery provided the juice to be able to turn that engine over with authority. Started up, no problem. So I'm pretty happy about that. And, again, just to kind of talk about it a little bit more, initially during that video I talked about earlier, I made about a year ago, I wasn't going to replace that battery. I figured I could just rely on the pull start, but based on the comments to that other video from some of the people that watched it, I had to agree with them. It's a good idea to have that electric start and use that as your primary method for starting your inverter. If that fails for some reason, well, now you've got a plan B. You can use that pull start. If I'm only relying on the pull start and something happens there and I don't have this available to me, well, then I'm screwed. If the lights go out or the power goes out rather, and I need to get my refrigerator running, or I want to power some lights or whatever it is, and this thing fails, that's going to be miserable. I would be really, really bummed. So plan A, if that fails, I've got a plan B. So no matter what happens, I should be in good shape. Something else I'm going to start doing that I've not done previously that I got to believe is a pretty good idea is that I'm going to come out every 4 or 5, maybe every 6 months and start this and let it run for a half hour or so. I think that's going to be better for the machine mechanically to kind of get those internals moving around a little bit. And it's also going to help ensure that that battery stays topped off and that it has juice in it. If I let this thing sit for a year or two and then I need to rely on it and I hit that starter button, it may not work. So again, just having that machine run periodically to keep juice in the battery, I think is a solid plan moving forward. Well, that's going to do it. We got the battery replaced. This thing's going to be ready to go when I need it. If you enjoy content like this and you're not already a subscriber, make sure you hit that subscribe button. Thanks for taking the time to watch. I appreciate it. Be safe. Enjoy the rest of your day.